Welcome again to this video tutorial series of TwinSimulate. In this video, we'll be looking at MQTT protocol and how it's supported in TwinSimulate. For folks who are not familiar with MQTT is a very popular protocol, generally used in IoT domain. The protocol itself is a client-server publish-subscribe-based protocol where messages are passed through a broker, generally called an MQTT broker. Devices can publish and as well as subscribe to what we call topics. And the broker somehow manages this as a central manager of all these messages and, handles all the publish and subscribe transactions. MQTT is gaining a lot of popularity, especially because it's very, very lightweight. It's open and simple and can be very easily implemented, both for purposes of testing on a PC, or it could also be in microcontrollers. MQTT is finding its application in a lot of areas, in smart homes, for example, lighting, HVAC, security systems. It's also finding use cases in automotive where people want to look at electric vehicle telemetry, diagnostics, fleet tracking, and so on. You could also monitor weather, plot some weather data, temperature data that's grabbed from an edge device and send it to a cloud and so on. Similarly, in the healthcare domain as well. TwinSimulate makes it very, very easy to handle transactions via this MQTT protocol, especially for the digital twin applications where you might have reduced models or mathematical models of real systems. You may want to also collect data and run them against your models, or maybe you want to create a virtual sensor model and so on. MQTT has two main transactions that are possible: publish and subscribe. Let's move on to a demo and see how these things play together in TwinSimulate. Here we are in TwinSimulate. In this case, you see a very interesting model. It's a model of a battery, a single cell. It's set up in such a way that you can measure the state of charge as well as the open circuit voltage for an equivalent circuit model of a battery cell. I'll not go into the details of how the battery cell is modeled here, but these are straightforward equations that can be put together as a virtual model and then can be simulated for, cycles and so on. So current model is set up to run for about 40 seconds. And we start with an initial SOC, state of charge, and then we look at the current draw and the load, and then see how the battery discharges over a period of time. You would expect that the state of charge goes, lower from the full capacity over a period of time. Same with the open circuit voltage. What's interesting is, if you had batteries in the field and you want to kind of monitor them and see how these things are going, you may want to also look at posting the data over to the cloud and maybe perform some good analytics on it. So in this case, we're looking at a platform from Zoho, which is an IoT platform. It could be any other platform, but for the demonstration purposes, we picked this particular platform. What you see is an MQTT publish block. The MQTT blocks can be found in the communication category of the library. As you would imagine, there is an MQTT publish and as well as a subscribe block. For the demonstration purposes, we are using an MQTT publish. When you look at these kind of blocks, they have a lot of parameters. that are very specific to MQTT. And there's also parameters that are related to the data that you want to post. Especially for certain platforms, like for example, the Zoho IOT platform in this case, has specific needs. It has an IP address, a topic to which you want to send the telemetry. There is some username, password, and then comes the data. The data itself is state of charge and open circuit voltage in this case. The IoT platform expects everything to be packed in a JSON format. The MQTT communication to a Zoho IoT platform is run to a TLS security. There are port specifications that are provided by the vendor there. The quality of service gives you a way to kind of choose between 3 different levels. You can have a QoS 1, 0, and 2. Depending on what you want to set up, you can put those parameters in. The device ID is specific to a particular case here for the IoT platform. And then if you're dealing with secure communication, you could also have certificates that you want to go ahead with. And that's it. You connect the right data that you want to post to the cloud platform, and then run simulations, and hopefully the data should show up on your cloud. Now let's switch over to the IoT side of things. For the demonstration purposes, we are using the IoT platforms of Zoho. You could find that information in terms of how you can add devices. I'll not go into that. But the concept is to basically add any number of devices and kind of prepare the schema towards what data you want to kind of acquire through whatever protocol. In this case, it's I've added a device called battery. And you can look at, there are a device here. You can look at all the details. You can also, if you want to look for the connection details that you want to put on your TwinSimulate block, all of these are parameters that goes into the TwinSimulate dialog. And you can also have the certificate downloaded and added into your parameter dialog as well. So that's it. So once you have some devices set up, you can also test if the messages are coming through, and then build up a dashboard to see what kind of data is coming through. Now, for the moment, I'm going to just put up my model side by side, and what you're going to do is run this. The simulation starts to run. It finds the connection, and then in a matter of time, you should see that the data starts to flow. So the model is running. It's trying to connect to the cloud platform in this case. Now the data is going through. To be efficient, we also post the data at a slower interval because, the data ingestion can be, accordingly taken care. And once you see the live data, you can see that the data is coming through. As you can see, it updates live, as in when the data is, updating in your simulation model. Of course, if you want to see a very, very interesting, fast streaming, you may want to, reduce the data rate. But for the demonstration purposes, I kept the update rate to be slower. And that's it. That's how easy it is to set up your digital models, connect them to the cloud platform, and then you can do interesting analytics on the cloud platform, look for diagnostics, prognostics, maybe also do some analytics on top of the data that we have acquired. I hope this was useful. Thank you. Stay tuned for the next video.